Is Algebra 2 lesson 13.4. We're doing inverse trig functions. So we have a box talking about the inverse of tangent and cotangent and sine and cosine. The first one says if -1 is less than or equal to a, and a is less than or equal to 1, then the inverse sine of a is sine, when you see this symbol right here, and you can see these when you look at your calculators, sine to the -1 right there, that's talking about the inverse of it. You only use that button on your calculator when you're looking for an angle measurement, and I'll show you how that. That's when we're going to get to example number 2, not the ones we're looking at with example 1. But it says a is equal to theta, where sine of theta is a, and the negative pi over 2 is less than or equal to theta, and less than or equal to pi over 2. All of that is very, very confusing. Okay, so let's look at it. Let's try to make it less confusing. Or it's just saying -90 degrees is less than theta, less than +90 degrees. So it's talking about this side right here. You can do the same thing with um, cosine, but it's talking about from 0 to 180. And with tangent, it's talking about from -90 to 90 again. So again, let's make that make a little bit better sense with the first example. It says evaluated in both the radian measurement and in degrees. Remember, radian is the distance around the circle. You start at 0 and you start going in an arc, the distance around, if you're confused. Degrees is how much the angle opens up. So it's saying the inverse sine of 3 over 2. So if you look at your unit circle, this is the fastest way to do this. You look at your unit circle. Remember what sine is. Sine, SOH, S-O-H, is what you're dealing with sine, S-O and H. So it's opposite over hypotenuse. Remember, the hypotenuse is represented as 1 because it's talking about the radius being 1. The opposite is the y value. So you're looking at your y value of being 3 over 2. So if you take a look at all your unit circle that I gave you guys that we filled out, none of the y values just say 3 over 2. Some of them say the square root of 3 over 2, but none of them just say 3 over 2. That's why there's no angle whose sine is 3 over 2. Therefore, therefore the inverse of sine of 3 over 2 is undefined. There is no such thing with something like this. On the other hand, when you're talking about the inverse of the tangent of the square root of 3, now tangent, remember SOH, T-O-A. When you're talking about tangent, it's opposite over adjacent. So again, if you're looking at your unit circle just on a little shrunken down version, if we're talking about this triangle here, the opposite over the adjacent. This is your opposite. This is your adjacent. So remember, this over here is your y side, and this right here is your x side. So opposite over adjacent. So it's talking about um, the square root of 3. Now, if when you look at it, you don't see any x's or y's that just say the square root of 3. Some of them say the square root of 3 over 2. In fact, all of them except the ones at 45 degrees have some version of the number, the square root of 3 over 2 in it. Some of them positive, some of them negative, some of them on the x, some of them on the y. As you look at all of your opposites, the ones that say square root of 3 over 2, those are talking about your y values. So notice at 60 degrees, it says the square root of 3 over 2. At 120 degrees, it's the square root of 3 over 2. At 240 degrees, it's negative square root of 3 over 2. And at 270 degrees, it's negative square root of 3 over 2. So you're talking about, just like on the bell work, you're talking about the ones that are at the 60-degree marks all the way around. So again, on your unit circle, you're talking about this angle here, this one, this one, this one, and this one. And again, we don't use y as your reference angles, but we're just showing you the ones that are at 60 degrees all the way around. So all of them have in their y value the square root of 3 over 2. The x values of all of those are 1/2. So it's opposite over adjacent. So opposite And again, if you're using it as part of a reference angle, it's going to look like this. We're going to talk about those. The red ones, not the blue ones. Opposite over adjacent will be the square root of 3 over 2. The square root of 3 over 2. And it's opposite over adjacent, so it's that divided by the adjacent 1 over 2. Now, this is dividing fractions. Remember, how do you change division of fractions, or how do you simplify dividing by a fraction? You change it to multiplication, and then what do you do with the bottom number? Again, if you need to write it this way to make it make better sense, it'll make better sense to you. If you need to write it instead of doing it over it like that, put them next to each other. This divided by that. So now it says the square root of 3 over 2 divided by 1/2. Remember, leave the first fraction, the square root of 3 over 2. Change it to multiplication. And what do you do with 1 over 2? When you change division to multiplication, what do you do with 1/2? You use the reciprocal. You flip it. 1 over 2 flips and becomes 2 over 1. Remember, anytime you multiply the same thing by each other, that's the same at the bottom and at the top, you can cancel it out. So 2 cancels out 2. And what you're left with is the square root of 3 over 1, or simply the square root of 3. So for this one, um, the tangent or the inverse of the tangent of theta of the square root of 3 is pi over 3. So the only one we're going to use is this one right here, this position, because the rest of them will give you a negative version when you do that. So the square root of 3 over 2 is pi over 3. That's its radian measure, pi over 3. And again, that angle right there as a degree measure is simply 60 degrees. So pi over 3 and 60 degrees. Let's look at a couple more examples to make this make better sense. I know this is confusing. At the end of this, it's going to be less confusing. On the back, what about the inverse of the sine of the square root of 2 over 2? Again, that's not negative square root of 2 over 2. That's simply the square root of 2 over 2. Remember, it's talking about sine. SOHCAHTOA. S-O-H. So which value is it talking about? X or Y? So as you look at this one, you can say it's possibly talking about two angles. Remember, sine is the opposite over the hypotenuse. So when you look at your unit circle, which ones have the square root of 2 over 2? Notice there's 4 of them all the way around that have the square root of 2 over 2. All of the ones that are halfway through 90 degrees. So all of them that are at 45 degrees have the square root of 2 over 2 as the numbers that make up their x and y values. Remember, sine is opposite over hypotenuse. Hypotenuse, or the radius for all of these, is going to simply be 1. Okay, all of those is going to be 1. But remember, on your reference triangle, this part right here identifies which ones are your opposites and which ones are your adjacents, this one and this one. So again, opposites, when you're talking about the angle theta from the central angle, this part is the central angle all the way around, no matter how far you have to go. The opposite is going to, since it's sine, is going to be the one that's straight across. So you're talking about, for all four of these, you're talking about their y values. Each of the y values. Those are the opposites. Opposite over hypotenuse. So as you look at all the 45-degree measures, all of them, both the x and the y's, are the square root of 2 over 2. So you have to pick out which one's the positive version of the square root of 2 over 2 on your y value. As you look at the first one, this one here, both of them are positive, square root of 2 over 2, both the x and the y. As you look at this one here, the x is negative, but the y is positive, square root of 2 over 2. As you look at this one down here in the third quadrant, both the x and the y are negative. So this one we know is positive, positive. This one here is negative, positive. This one down here, both of them are negative. And then finally, this one right here, it's positive, its x is positive, but its y is negative. Again, all of them say the square root of 2 over 2 all the way around. But the only ones that's y values are positive are the two that are on top. So you're going to ignore this stuff down here. You're just going to look at the two midway angles on top, where they both say the square root of 2 over 2. So it says to identify it in both radians and degrees. So let's just clean it up where we can see it a little bit better. We're talking about this angle measurement, which is 45 degrees. And we're talking about this angle measurement here, which goes all the way to there, which is 135 degrees. So both of those, that's the degree measurement for both of those, which both of them have the inverse sine of the square root of 2 over 2. The radian measurement for the red one, as I have it listed, is pi over 6. And the radian measurement of the blue one, as I have it listed, is 3 pi over 4. Remember, that's talking about the distance around the circle.